this performance final review, I'm going to go through all the different equations that you've had throughout the semester that would likely show up on a performance final. Starting off with 1D motion, and these are all your equations. Make sure you use your equation sheet and know where to find the equations when you need to. Starting off with this first problem, what is the distance? What is the x traveled after 1.5 hours? So that's going to be your time, 1.5 hours. Now this is not seconds, so it's going to be important for the end of this question. And going at a speed of 50 kilometers per hour. And hours they match up, so I don't actually have to convert unless it asks me to convert, which it doesn't. And we're going to go to the equation v equals x over t, and we're solving for x, so we can rearrange this, get rid of the t by multiplying both sides by t, and x equals v times t. X equals v, which is 50, t, which is 1.5, so we get 75, and since the hours are going to cancel out in this, we're going to be left off with kilometers. So there's our answer. What's your average speed? So what's your velocity? If it takes 5 hours, time equals 5 hours, not seconds. Tempting to do that. Hours to go distance, displacement of 400, I guess it's distance because it doesn't tell you where, just 490 kilometers. And we're going back to the v equals x over t equation because it doesn't tell me I'm speeding up or slowing down. So it's just going to be v equals x over t, and it's going to be 490 kilometers. And the time's going to be 5 hours. You type that in the calculator, 490 divided by 5 equals 98. And it's going to be, we used kilometers and hours. So this is going to be kilometers per hour. So there's our answer. Okay, a student drops a 1 kilogram rock from a bridge 23 meters below. How many seconds does it take for the rock to hit the ground? When you write out all the variables, the vi equals 0, the x equals 23 meters, really y, and I'm actually going to use an equation where that's y. Does it take the rock to hit the water? Acceleration is going to be falling in the air, so 10 meters per second squared. And how many seconds? Time is asked. So normally you would go to this equation right here with all my givens that I have, but there's a special equation right here. This is in the 2D motion section. And if you forget g, I use 10, but g is 9.8 or 10, whichever one you want to use. So it's going to be t equals square root of 2y over g, and so I'm just going to cross it out and make that my y, and I'm going to cross it out and make that my g, because that's all it is really when using this equation. And so it's going to be square root of 2 times 23. So 2 times 23 over, and g is going to be, I use 10, but you could use 9.8, either one would work fine. Just make sure everything's in parentheses. 2 times 23 divided by 10, square root that answer, and I get 2.14 seconds. Okay, how fast is the rock moving? So VF equals question mark. When it hits the water, same givens from before. VI equals 0. G equals, or acceleration due to gravity equals 10 meters per second. And I even have a time now, 2.14 seconds. So I can pick many equations. The easiest one to go to with my givens that I have here would be the VF equals VI plus AT. So I'm going to go to that one. So VF equals VI plus AT, but there's many that work, and if you pick the right, no matter what you do, if you use the right numbers, you're going to get the right answer. Plus A, which is 10, times T, which is 2.14, and I only have to do the math. 10 times 2.14 is going to be 21.4 meters per second. Once again, back to meters per second because it didn't tell me otherwise, and I was using meters and seconds in my work until now. What's the acceleration after 1 second? 10 meters per second squared down. After 2 seconds, 10 meters per second squared down. Once again, 9.8 could work just fine for either one, but it doesn't change. If the ball's in the air, and we're not talking about the air resistance terminal velocity or anything like that. We're going to free fall would be just 10 meters per second squared always. Okay, so that gets us to our acceleration equations, which we already kind of did a little bit, but what's your deceleration? If you take 3 seconds to slow, so time equals 3 seconds to slow from initial velocity of 20 meters per second to a final velocity of 15 meters per second. And what is your deceleration, which is really asking you what is your acceleration, it's going to be a negative. And so A equals VF minus VI over T. A equals VF is 15 minus 20 over time of 3. And we're going to end up having 15 minus 20 is going to give you negative 5. Divided by 3 gives you negative 1.6. Let's just go with 67 meters per second squared. That's our deceleration. Okay, what's your acceleration when it takes 7 seconds to go? So same sort of problem. T equals question, or T equals no T. A equals question mark. T equals 7 seconds. VI equals 30 meters per second. VF equals 40 meters per second. A equals VF minus VI over T, which equals VF, which is 40 minus 30 over time of 7. So 40 minus 30 is 10 divided by 7 gives you, and it ends up being 1.4, let's go 3 meters per second squared. And so that's our answer there. What's your acceleration when traveling a constant velocity of 55 meters per second for 25 seconds? Explain your answer. So V equals 55. This is not a problem you'd have to do math on. It doesn't change. VI equals 55 meters per second. VF equals 55 meters per second. And constant velocity means that acceleration equals 0. You don't have to do any math, but if you did, A equals 55 minus 55 over 25, which equals 0. Either way, when you see constant velocity, just watch out. That means no change in the acceleration, or that's zero acceleration. But if you see constant acceleration, that doesn't mean A equals 0. That means there is an acceleration of something. So that would be a different problem. Just watch out for that. How fast is an object moving after falling 8 meters? Okay, so any object starting from rest, falling a distance of 8 meters, VF equals question mark, A equals 10 meters per second squared. Okay, so you're falling from rest. So what has VI, X, VF, and A in it? VI, VF, A, and X right there. So VF squared equals VI squared plus 2AX. So VF squared equals VI, which is 0 squared, plus 2 times 10 times 8. And so that's going to cancel out. And so you're going to have VF equals, I'm going to have to take the square root of both sides. And so the square root of 2 times 10 times 8. So square root of 2 times 10 times 8 ends up being 12.64. So let's go ahead and go with 12.6 meters per second. Next one, what's the force of a 3 kilogram physics book that falls freely due to gravity? So drawing a force diagram of that. That would be the weight of the object, and weight equals mass times gravity. That is a mass. So mass equals 3 kilograms. And G equals 10 meters per second squared down. And now we can solve for weight. Weight equals 3 times 10, which is equal to 30 newtons. And I can even plug that, I can always throw that back in here. And this would be a free body diagram of this picture right here. What does acceleration due to gravity mean? So A is really G, which is equal to 9.8 meters per second squared, or 10 meters per second squared. And so what that means is that every second an object falls, and that should be down, 10 meters per second. in a downward direction faster. And so that's what it means right here. So if something started off at 0 meters per second, after 1 second, after 2 seconds, after 3 seconds, after 1 second, it would be going 10 meters per second. After 2 seconds, it would be going 20 meters per second. After 3 seconds, it'd be going 30 meters per second. So that's what it means to change your velocity by 10 meters per second every second down. Okay, here's your projectile motion section. And so this is where you have your G if you ever need it. You got your time. This is just a shorthand of the x equals VIT plus 1/2 AT squared. When VI equals 0, this part right here cancels out, and then you rearrange that. And when you rearrange it, it rearranges to this. So it's just a cheap way to go quickly to it. Okay, and so projectile motion, we want to go ahead and it's independent motion, x and y. Things that we know here, it's for horizontal projectile motion. Well, VI equals 0, A equals 10 meters per second squared down. Okay, so we have a 3 kilogram ball, and mass doesn't matter. It's kicked 8 meters per second from a cliff 80 meters high. So it's going to be kicked horizontally. It should say horizontal, but it doesn't. Vx equals 8.0 meters per second. So it's going to be going that way. And the cliff is going to be x. So actually, in this case, we'll just go ahead and go with y since we're going to use these projectile motion equations. And we can go ahead and call that g2. Y is going to be equal to 80 meters. How long does it take? So we can solve for time there. And after we solve for time there, we'll have time here. And then we can use that to figure out how far away it's going to land. So t equals square root of 2 times 80 over, we'll just go with 10, but you can use 9.8. And when you do that, 2 times 80 divided by 10, take the square root of that answer, and you get 4. So that's going to be 4 seconds. So 4 seconds. And then now, after we get 4 seconds there, now we can go ahead and finish it off doing this equation, x equals v times t. And so we're going to go ahead and get v is 8, t is 4, and you get 32. 8 times 4 equals 32 meters. What's vertical acceleration? It is always going to be 10 meters per second squared down, or this right here. So either one would be fine. Okay, next part. You launch a 1 kilogram ball. You don't need the kilograms, moving horizontally. So you have x and y givens. You have a Vx of 1.12 meters per second. Table is a y of, its height is 0.77 meters. How long does it take to hit the ground? Well, other givens, Vi equals 0. The acceleration equals 10 meters per second squared, or in this case, g is going to be 10 meters per second squared. And then we're just trying to find time to start off with. So t equals square root of 2y over g. That equals square root of 2. The y is 0.77 over 10. Make sure all of that is underneath the square root. So 2 times 0.77 equals 1.54. Divide that by 10, you get 0.154, and you take the square root of that answer, and you get 0.39, and that's going to be seconds. Okay, so how far from the table will it land? Well, back to x equals v times t, or vxt, and so that's going to be, it's going at 1.12 meters per second. Don't want to put that in my calculations. It's going to do that for 0.39 seconds. So 1.12 times 0.39 equals, and that's going to be 0.4, let's go with 44 meters. So that's how far out this ball is going to land. Ball is kicked horizontally. I have to click it at 15 meters per second. How high was the cliff? Okay, so we have x and y givens. Our Vx is 15 meters per second. The ball landed 83 meters from the base. So what this is saying is right here is 83. So therefore that's going to be this, 83 meters. And the question is this right here. How high is the cliff itself? Okay, so we can find our time. We're going to start with time here, and then we'll go ahead and we'll plug that into the y-axis and go from there. But other givens that we have, vi equals 0, the acceleration due to gravity, the a equals 10 meters per second squared down, and we have everything we need to get started. So v equals x over t, d, divide out the v, divide out the v, and you get t equals x over v. Or another way, you just go from there and you divide out you end up getting the same thing. Divide out the v, and you get this. And so that's going to be 83 meters it travels, and if it travels at 15 meters per second, we figure out 83 divided by 15, and you get 5.53 seconds. Well, that's how long it has now to fall. So time equals 5.53 seconds. And we can solve for y with that information. So y equals VIT plus 1/2 GT squared, or 1/2 AT squared. So using that equation, this would be G, and it's like VIY. Once again, it doesn't really matter as long as you realize what you're doing, what you write in your givens list, as long as it's there. So our y is going to be equal to 0 times the time of 5.53 plus 1/2 times, I'm using 10, or you can use 9.8, times 5.53, and only the 5.53 is squared. And so we don't have to worry about this first part. It's going to cancel itself out when you do it. 5.53 squared equals 30.5809 times 10 times 0.5, and you get 153. I'm just going to go 53 meters. So that's how tall this cliff would have been. Okay, then now we're on to Newton's laws, force and weight. What's the force needed to lift a 40 kilogram weight? Well, you're going to need to lift it by its weight itself, and this is mass. Mass equals 40 kilograms. So if you find the weight, that's going to be the force needed to lift this object. So that is mass times gravity. Mass is 40. Gravity, once again, the acceleration due to gravity is 10 meters per second squared down, so 400 newtons. So you have to lift its weight. To lift its weight. And this would be for constant motion. This is the minimum you need to be applying. If you want to accelerate it, you can apply more than that. Okay, explain the relationship between mass and acceleration in the formula. And they are going to be, so if force is to stay the same and I make mass go up, acceleration goes down. So they are inversely related. So if force was 1 and I made mass 2, then acceleration would have to be 1/2. And if I made acceleration 2, then the mass would have been 1/2 to make it equal to 1. So if one goes up, the other one goes down. If that went down, this would have to go up. Okay, a box weighing 6.65 newtons is sitting on a frictionless counter. Draw a force diagram of this. Well, they go ahead and they give you the weight because they're giving you in newtons, 665 newtons. And it's sitting on a counter, so it's going to have a normal force of 665 newtons as well. Okay, and now when you switch it up a little bit, if there is an acceleration of, so 665 newtons is the weight, and 665 newtons is the F normal. But then also you apply a force of 777 newtons. Well, these are going to cancel off, but this one won't. This would end up being your net force. And so now it's going to cause an acceleration. But in order to do that, let's go ahead and figure out what the mass of this object is. So Fw equals mass times gravity. In this case, Fw equals 665 newtons, and the gravity is 10 meters per second squared. And so we have, when we're trying to find mass, equals Fw divided by g, which is 665 divided by 10, or 66.5 kilograms. And now we have that. Now we can go ahead and do the F net equals mass times acceleration. And we can go ahead and rearrange it. A equals F net over mass, which equals 777 over 66.5, which equals 11.7 meters per second squared. Okay, what distance does the box travel? It accelerates for 3 seconds, so t equals 3 seconds. Our VI equals 0. Our acceleration equals 11.7 meters per second. And what distance does it travel? It's asking you for x. So x, VI, t, and a, we go back and look at our equations. X, VI, t, and a, I think that's going to be, let's go back for a second. So looking back at all the way back to these equations, and x, VI, t, and a, there you go, right there. So x equals VIT plus, erase that, plus 1/2 AT squared. And so what's the distance if it started from rest for 3 seconds? Acceleration is 11.7. Once again, this object's not falling through the air. It's doing what they're telling you it's doing, so it's not 10. Squared, and we plug that in. So 3 squared equals 9 times 11.7 equals times 0.5 equals, and I have 52. Go back. It's going to end up being 52.65, or let's go and go with 7. And that's going to be meters. There's your answer. Okay, it's 90 kilogram parachute falls towards Earth at a constant velocity. Constant velocity means A equals 0. I don't have to do anything else. What's acceleration? Well, A equals 0. There's constant velocity. If I was going to draw this force diagram, it would be a weight of 900 newtons, because it would have been 90 times the 10, and the air resistance would be equal to 900 newtons. So this person would be at terminal velocity. Okay, and then we get into our universal gravitation. What's the attraction force between 48 kilogram mass and another? So we're going to have mass 1 equals 48 kilograms. Mass 2 equals 70 kilograms. The distance apart is going to be 16 meters. And what is the attractive force, which would be the force of gravity? And then we have our g over here. So Fg equals 6.67 times 10 to the negative 11th. Times mass 1, which is 48, times mass 2, which is 70, divided by 16, and that has to be squared. So we get 6.67 second EE negative 11 equals, and that gives me that G, times 48 times 70 equals, right now I have 2.24 to the negative 7th power in my calculator, divided by, open parentheses, 16 squared, close parentheses, equals, and I get a force of gravity of 8.75 times 10 to the negative 10th newtons. And so that would have been 0.90, then that 875. It would be a really small number. Okay, mass of 10 kilograms is next to another mass, 15 kilograms. What is their force of attraction when the distance apart is equal to 1.15 or 1.5 meters? So we go Fg equals g m1 m2 over d squared. Once again, good practice to write down the equation before you use it. 6, 7 times 10 to the negative 11th times the 10 times the 15 over 1.5 squared. You're less likely to make this mistake, and you can compare what you did if you do make a mistake. That's why it's important to do a little extra step. So 6.67 second EE negative 11 equals, I get that in my calculator, remember, times 10 times 15 equals, I have 1 times 10 to the 8th, negative 8th right now, divide that by open parentheses 1.5 squared, close parentheses equals, and I get 4.45, I'll go with that, times 10 to the negative 9th newtons, and that will be the attractive force, so very, very small. 0.80 is before this 4. Okay, explain how distance impacts the force of gravity between the two masses. So Fg equals capital G m1 m2 over d squared. And so if that is increasing, then the force of gravity is going to be decreasing, but not just decreasing, but decreasing rapidly. So it's going to be, when that's increasing, that is decreasing faster. And that would look like Fg equals, and there's your distance. It's going to look like, that's not a good drawing. It's going to be really quick at the beginning, and as you get closer to 0, it's not going to really make a big difference. But at the beginning, it's going to go down. The force of gravity is going to decrease rapidly. So distance has a huge impact on the force of gravity. Okay, centripetal force. Okay, what's the centripetal force of a 100-kilogram object traveling at a speed of 20 meters per second tangential in circles that have a radius of 10 meters per second? Okay, so I have everything I need. Let's just go ahead and write down your givens. M equals 100 kilograms. Velocity equals 20 meters per second. Radius equals 10.0 meters. And we're asked for centripetal force. So F C equals question mark, and FC equals mv squared over r, which equals m, which is 100, times v, which is 20 squared, over r, which is 10. So 100 times 20 squared, don't forget the square root of 20, divided by 10, and you get 4,000. So it's going to be 4,000 newtons of force directed inwards in order to have circular motion going on. Okay, what's the centripetal force of a 75-kilogram object? So it's giving me all the information again. Mass is 75 kilograms. The velocity tangential is 80 meters per second. The radius of the circle is 100 meters, and they're asking for centripetal force. So Fc equals mv squared over r, which equals to, in this case, m is 75, v is 80 squared over r, which is 100, and that's not squared. So 75 times 80 squared equals, divided by 100 equals, so I get 4,800 newtons. So let's just double check. 75 times 80 squared. Only the 80 should be squared, divided by 100. And yes, I get the same thing, 4,800 newtons. Okay, a record takes 1.15 seconds to make one complete rotation. This is telling me that the period is 1.5 seconds. This is not just a time, but 1.5 seconds for that period. And what's the tangential velocity at a spot that has a radius of 0.25 meters from the center? So it's telling me, so this is 0.25. And the time it takes is 1.15 or 1.5. And once again, when it's the time it takes to do that, this becomes a capital T when it's for the time for one rotation. So to go around once takes 1.5 seconds. And so we have V equals 2 pi r over T, which equals 2 times 3.14, or you just hit the pi button in your calculator. Times r, which was 0.25 over 1.5, and that equals, so 2 times 3.14 times 0.25 equals, divided by 1.5 equals, and I get velocity of 1.05 meters per second. Okay, another tangential velocity equation. So the object is rotating with a radius of 0.25 meters from the axis, from the center. So that's a little sloppy. Let me erase that and let's do that again. R equals 0.25 meters, and it takes 0.05 seconds to make one complete rotation. So that's period. V equals 2 pi r over capital T, which equals 2 times 3.14 times 0.25 over 0.05, and so you get 2 times 3.14 times 0.25 equals, divided by 0.05 equals, and you get 31.4 meters per second. Okay, next one, work power energy. Okay, a large rock with a weight of 1475 newtons rests on top of a cliff that is this tall. What's the potential energy? So PE equals mgh. So the mass is, okay, I need to find the mass. That's not mass, so this is going to be the FW. So I need to do FW equals mg first. M equals FW over G. So mass equals 1475 divided by the 10. So 147.5 kilograms. That is the mass. So now I have the mass that I can plug into here. So mass is 147.5 kilograms. Gravity is 10. It is on top of a cliff that is 122.5 meters tall. So 147.5 times 10 times 122.5 equals, and I get a potential energy of 18068. Let's go ahead and go with 8 because I have 8 goes to 5. So I have a potential energy of this many, and remember joules is the unit for work. Okay, so how much potential energy will it have when it strikes the ground? Well, this potential energy right here will end up being the final kinetic energy, and we would write that by saying KE final. So at the top we have 180, so at the top we have this, and at the bottom it all converts to kinetic energy. Therefore, 180,688 joules. Okay, and then what would the speed of the rock be at the bottom? So at the bottom we have this. So Ke equals 1/2 mv squared. So we have mass of 147.5. We have kinetic energy of 180,688. And so if we rearrange this equation, we'll have everything we need to figure out the velocity. And so velocity is going to be equal to, so V equals, when I do the rearranging, V equals 2 times KE. So I got the 2 because I divided 1/2 by both sides. That gets rid of this. And then next what I want to have to do is I'm going to have to divide out the mass so I can get velocity alone. So at this point in time, I just got rid of this whole thing, but I still have the V squared. So then I'm going to finally take the square root of that. So V equals square root of 2 times this big number, 180,688. Let me erase that, put that somewhere else. So V equals square root of 2KE over M. The 2 Ke over m. M is the 147.5. Take all of the square root of that whole thing, and we get 2 times 180,688 equals 361376 divided by 147.5 equals, I have 2450 in my calculator, and then I take the square root of that answer, and I get 49.5 meters per second. Okay, and then lastly, an arrow has a mass of this. Mass is 0.384 kilograms, flies through the air with a speed of 24.73 meters per second. What's the kinetic energy? Straightforward, Ke equals 1/2 mv squared. K equals 1/2 times the mass, 0.384, times the velocity, 24.73, square that, and we get 24.73 equals, and take the square of that answer, so you get, do that again, 24.73 squared. I have 611 so far times 0.384. Now I have 234.8 in my calculator times 0.5 or divide by 2. Either one will do the same thing. And I get 117.4, and Ke is joules. That looks like a 5. Let me erase it. Joules. And there's my answer.